which of these processes is going on?
Respiration.
Respiration only, because it is in a dark scenario, okay? If it was uncovered and also lit with the lamp, what's going on?
Both.
Both. Oh. Both? Because some of you are telling me that respiration stopped, too. Okay? Respiration is going on non-stop, the whole time. The whole time. It is only when you turn on the light that you have both occurring. Okay? What we measured from this, I'm not going to write out the whole, equations again, but what we measured in this experiment was the up and down cycles of carbon dioxide gas they were being given off. And how this started out in our experiment, we divided this up into 15-minute intervals, did we not?
Yep.
All the way to 60 minutes. And the first interval of light, or the first interval, we had it covered up, if I'm not mistaken. It was with a foil, and then the second one was not foil, and then the foil again, and then it was back on. So here we had light and light in these 15-minute periods of time. And so what should be happening when the plant is experiencing a foiled up scene?
Respiration.
Which process? Well, first of all, which process is going on in this particular interval?
Respiration.
Respiration only. And if respiration only is going on then, what's going to happen to that gas?
C2 goes up.
It was on the rise. It was on the rise. And so your graph started cranking up like that when you did it. Then we took the foil off and we looked for what's going on at that interval of time. What's going on?
Both.
Both. Not just photosynthesis. A lot of y'all want to ignore that respiration is still going on. Okay? Since both are going on, it is the photosynthesis that will tend to recycle that gas for you and pull that gas. It kind of peaked and then it lagged and it came back down. Okay? Then we wrapped it back up again. What's going on? Respiration only. And the gas went back up in the next 15-minute interval. Then we unwrapped the foil, took it back off. Both was occurring, and the gas came back down. Okay? So you are going to be reading a graph tomorrow that shows a cyclic wave of gases of carbon dioxide going up and down. Okay? You are. And whenever you're on the rise, what is happening?
Respiration.
Respiration. Okay? And whenever you're on the decline, both. Okay? That won't be awful. That won't be awful. Now, look carefully. The question asks you, stare at your graph, during what intervals is respiration occurring?
All of them.
Oh, all of them. See, some of y'all want to blurt out right away. Just learn that one. Because you're forgetting, the thing respirates non-stop. Okay? Non-stop. It's not dependent upon is it in the dark or the light. Okay? All of them. Both means respiration as well. Now, if you are looking at what intervals, it was only photosynthesizing. This one is where students usually are okay because they know it has to be in the light. And they would know that when gas is on the decline, it's in a lit situation. Okay, so you will have to know the pattern. And we don't necessarily have to tell you all the tidbits that are here. Like this isn't going to be in front of you. Okay, these both are, etc. You got to know that by interpreting the graph wave. Okay, so that was that experiment. We used the plant ligustrum for that. So when you guys got your papers back today, your labs, I did circle the correct answers because darn near most of you missed all those increases and decreases and increases and decreases. So I did correct that for you on your papers. Okay? Now, what else did we do in this lab? We messed with the leaf that was called the coleus leaf. And if you remember, it had pretty colors on it. It had areas where it was green. It had areas on it where it was and it had areas on it that were pink, and your homework asked you for what were the names of these pigments in these areas, and what's the name? I'm not looking for color, name. This is something you've gotta watch tomorrow, because if the question says, name the pigment, you can't just say green, okay? You have to name the pigment. Chlorophyll, who's the pink one or the red one? Was anthocyanin. Who are you if you're white? You are neither. And if there was a place where both of them showed up together, it was that brick red, which we didn't get in our lab. But we did this, we decolorized it. One of these was alcohol soluble. That was the first or second one that it went in. But I think when you did this,
First one.
did you put it in a beaker of boiling water first, or put it in a little hot bath swimming in alcohol first? You put it in boiling water first. Which color went away then? Pink. The pink one went away. And if the pink one went away, that tells you that it's the anthocyanin that is the water soluble pigment. So sometimes in the middle of this, you think, what do we do in a lab? What happened while in the lab? Then it went to the alcohol bath, and then the liquid turned on green, right? You make green tea, alcohol soluble. Alright? What we did was we cleared the leaf of its color, added IKI, stained areas for starch. And where did the starch appear?
Green and red.
It would basically appear wherever there was green. And what I circled on your lab homework was that it does appear in any area that's green, whether it be where both the colors exist or just in green by itself. It's just going to appear anywhere there's green, period. Okay? Why? Because the photosynthesis needs the chlorophyll pigment to make the sugars that form the starch that's got to be in the leaf through the IKI. All right? And that was that plant. And then the last thing